Alrighty then, corn children, children of the corn. It is another fine day for learning. And today we're going to talk about infinite geometric series. What? That's right, infinite geometric series. All right, let's break it down. We'll break it down from the back. Series. This is going to be a pattern of numbers, and we are going to be adding them up. Again, it's the idea that you add together. Geometric, meaning that those numbers are following a pattern. To get from one number to the next, we're multiplying by the same thing every time. Here's the new kicker. Infinitely. We're not going to stop. We're going to add these things up forever. Now, you might be saying to yourself, if I add up a bunch of numbers forever that are following a geometric pattern, Now, get this. We don't stop. We go forever. Well, you would say to yourself, these are just going to get bigger and bigger and bigger. If you keep adding and adding and adding, this will automatically get bigger and bigger and bigger. And you would be right some of the time. Oh, no way. There's no way that it doesn't always get bigger and bigger and bigger. Well, let me explain. Here's an example. Consider with me two sisters. This is me, and this is my sister, Pete. Don't ask. Now, because we often play this little game of, I'm not touching you, I'm not touching you, I'm not touching you, my parents have put us 1 mile apart. But they're reasonable people, and so they said, well, you can move half the distance towards your sister. Okay, so we're 1 mile apart, and I am going to move half the distance towards my sister. So if that's 1 mile, I have moved a half of a mile. All right, so there we go. I moved half of a mile. And then I move half the distance again because I am a persistent bully. So if this was a half of a mile, I've moved now half of a half, also known as a fourth of a mile. So my distance so far is 1/2 and 1/4. All right? Yes, I keep moving in. I'm not touching you. I'm not touching you. Well, if that was a quarter of a mile, then I've moved half of a quarter, which is now 1/8 of a mile. So my total distance, I moved 1/2, then 1/4, then 1/8. And I move half of that distance. Now, obviously, the reality and the conceptual idea do break down, but we want to consider that I do this forever. That's right, I'm immortal. So I'm going to continue to move these distances, half, 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 half. And again, I can't move quite that close because I can barely walk and chew gum at the same time. I can't move like half the distance of an atom closer. But conceptually, we can continue this process forever. All right, so consider me moving half, 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 half. Campers, I am never going to move past my sister. I would always move closer to my sister. My distance will eventually equal 1. Now, I want that to soak in. If I can continue doing this forever, it is not approximate. The forever sum, the infinite sum, will equal 1. Mind's blown. I know. So why is it that some of these, oh, and by the way, this is an infinite geometric sum. Why is it geometric? Well, in the numerator, I'm multiplying by 1. In the denominator, I'm multiplying by 2. So the common ratio is 1/2. I am multiplying by a half every time. It is infinite, it is geometric, and we are adding them up. Here, we were multiplying by 2. It is infinite. We are adding them up. So why are some of these having an answer and some are infinite? Here's some key words. Why does this series converge, and why does this one diverge? Yeah, you get a number. This goes off to infinity. Divergent series can also go off to negative infinity. Or they can go and swing wildly, going way up to infinity, way down to negative infinity, way up further towards positive infinity. Why are some convergent? Why are some divergent? Okay, well, here's the key. It's the R value. When our R value is between -1 and 1, the series will converge and we will be able to find an infinite geometric sum. Wow, I know, that is so crazy. So hey, you may want to pause this video and you may want to jot this down. An infinite geometric series will converge, meaning you'll get a number for an answer, not infinitely large, if the R value, the common ratio, the number you're multiplying by every time, is strictly between -1 and 1. No equal to's there, people. Well, how on earth are we supposed to find that sum? Well, here's your formula. The infinite sum infinity, for a geometric, this only works with geometric series, is A1 over 1 minus R. It is so pretty. It's so elegant. I know, right? Right? All right, let's test this out, shall we? Now this next one, if you thought this blew your mind, it's, hold on, it's crazy. I want you to consider this. 0.9 repeating. Now, when I say repeating, it never stops repeating. It's repeating infinitely, forever. If you repeat forever, this equals the number 1. Fact. And some of you were like, no, it's just really, 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 really close to 1. No, it equals 1. Shut up. No, I will not, and I will now prove it to you. 0.9 repeating. Let me write it another way for you. It's 0.999 dot, dot, dot. Infinitely repeating. Infinitely. Well, let me break that down for you. Isn't that a 9 in the tenths place added to a 9 in the hundredths place added to a 9 in the thousandths place forever? Yes, it is, Mrs. Clyde. Yes, I thought so. And what I have now is an infinite series. Well, is it geometric? Well, to get from 0.9 to 0.09, I have multiplied by 0.1. If you don't believe me, 2 things you can do. Take 0.9, multiply it by 0.1, see if you get this. Take that, multiply it by 0.01, see if you get that. Or, how do you find an R value? Take 2 terms and divide them. The second divided by the first, out will pop the R value. So here's what I have now. Dot, dot, dot. It's infinite. I am multiplying by the same number every time. It's geometric. And what is R? R is 0.1, and the last time I checked, that is a number between -1 and 1. It has met the 3 conditions for being an infinite geometric series that will converge. I can find the sum using this formula. So if I add up all of these forever, if I find 0.9 repeating forever, it will equal a sub 1, 0.9, over 1 minus R, 0.1. Huh. Well, that, let me put it down here. 0.9 divided by 1 minus 0.1 is 0.9. Shut up. No, I will not, because it's true, people. It's true. After all, some of you are just blown away by this, but y'all bought into the fact that 0.3 repeating is 1/3. Well, if that equation is true and you multiply by 3 on both sides, doesn't this become 0.9 repeating? And isn't this 1? Ha! Told you so. Proved it in your face. Enjoy.